Hey guys, we're just going to work through the review for y'all's test. Okay, so first question, number one, it says simplify, and it gives us this rational expression. Okay, well, first step, guys, is to factor. Okay, so we open a tic-tac-toe box up, c squared, negative 72, multiply, we get negative 72c squared. Okay, and then negative 6t, so we're looking for two numbers that multiply to negative 72 but add negative 6. We do some thinking. Oh, okay. Negative 12c and why did I put a t there? I meant a c there. I put a t. I don't know why I put a t. Negative 6c and 6c because I was writing x. I don't know what's wrong with me. Because negative 12 times 6 is negative 72. Negative 12 plus 6 is negative 6. So c squared and negative 12c, what do they have in common? A c. C squared and 6c, what do they have in common? A c. C times what is negative 12c? Negative 12. C times what is 6c? 6. We go across, we go across. So this thing gives us c plus 6 times c minus 12 all divided by c minus 12. And then you should realize you can do something from there. You can cancel out the c minus 12s. So that gives me c plus 6. And that is my answer. Okay? Let's move on to number 2. Number 2 says t squared minus t minus 2 over t squared minus 4k minus 5. Okay, it's the same instructions as the first one, just simplify. And yeah, we're going to factor everything. That is our first step. Because we factor everything to see if there's anything we can cancel. Alright, so we write t squared, then we put a negative 2, and then we get negative 2t squared. Okay, we need two numbers that multiply negative 2t squared but add to negative t. That's going to be, you're right, negative 2t and 1t. T squared and negative 2t, what do they have in common? T. T squared and t, what do they have in common? T. T times what is negative 2t? Negative 2. T times what is t? 1. Go across, go across. So our numerator becomes t minus 2, t plus 1. Okay. Now we need to factor that denominator. Okay. So we factor it. Another tic-tac-toe box. We do t squared, negative 5, negative 5t squared. Alright, and then negative 4t. Oh, I threw a k right there. You guys will not see that when you actually get this paper. But I just realized I accidentally put a k there. There we go. Okay, sorry about that. Alright, two numbers that multiply negative 5t squared but add negative 4t are, that's right, negative 5t and t. T squared and negative 5t have a t in common. T squared and t have a t in common. T times negative 5 is negative 5t and t times 1. Go across, go across. So we get t plus 1, t minus 5. Then hopefully you notice, oh, I have t plus 1 so I can cancel out. So I end up with t minus 2 over t minus 5. Bam. And that's a minus sign, not a multiplication sign. Okay. All right, let's go to number 3. All right, number 3. Okay, so it says simplify. Those are still the same instructions for number 3. The thing is that hopefully you guys start off like, there's nothing to factor. Right, there is nothing to factor. So what's going on between these two fractions? These two fractions are multiplying. Okay? So that means that you just multiply top to top, bottom to bottom. Alright? So you get 3 times x to the 5th, y to the 5th. So when you multiply that, you just get 3x to the 5th, y to the 5th. Over, okay, 10 times 10 is 100. And then you get x squared, y squared. Okay? And then you just see if there's anything you can reduce. Well, we have 5x's on x to the 5th on top, x to the 2nd on bottom. So that becomes x to the 3rd on top. So we get 3 x to the 3rd. And then y to the 5th over y squared is y to the 3rd. All over 100. Alright? And then 3 and 100 don't have any numbers in common, so I can't. So that's as far as I can go. That right there. Alright? Number 4. Number 4 says x squared over x minus 3 plus x squared minus x minus 6 over x squared plus 1x. So we're multiplying these two fractions. But hopefully you're like, oh, okay, I can do some factoring here, and I can do some factoring here. And we're going to talk about those two factoring. The first one, so I'm just going to write x squared x minus 3 again. That just comes from this left fraction. I'm just not doing anything to it. There's nothing you can do. Times, okay, let's factor x squared minus x minus 6. So draw yourself tic-tac-toe. You get x squared, you get negative 6, you get negative 6x squared. All right, that's a negative x. So we need two numbers that multiply negative 6 but add negative 1. That's right, negative 3x and 2x. X, negative 3, 2. So this numerator becomes x minus 3x plus 2. X minus 3, x plus 2. Now look at this bottom denominator. Look at this bottom denominator. X squared plus 1x. You might be tempted to try to tic-tac-toe, and usually I would say go for it. However, do you guys just notice there's only two terms here? And not only that, do you notice that they have a number, they have something in common? Yeah, they both have an x in common, right? So you can start off by doing x times x plus 1. And so now what you can do is just look and see, can anything cancel out? Well, these x minus 3's can cancel. You have an extra x here and an x squared here. That's right, you can cancel this out to make this become just x. So you end up with x times x plus 2 all over x plus 1. All right? And you can't do anything after that. So let's move on to number 5. Number 5, rewrite the quotient as a product. Don't simplify, simply keep, change, flip. Okay, so I know in my third period, we definitely talked about keep, change, flip. Some other classes, you guys really like the butterfly method, and that's fine too. Just pay close attention to the question. Rewrite the quotient as a product. So that means that to keep, change, flip, you would keep this one, change to multiplication, and flip this one. Okay. For my other two class periods that really like doing the butterfly, tray method, whatever, think about how that's going to rewrite this. It's going to become 3x times 17y squared. So it's going to be 3x times 17y squared over 7y times, we already have the times, it's right there, 9z. Okay, I'm just kind of trying to get you to look at it like the way the test is going to ask you, okay? Most of y'all could do this, and you would write something similar to this, but this is how the test actually puts your answer, so I want to make sure you get a chance to see it. Okay? All right, and that's all. It doesn't ask to simplify, it just asks for you to do that. All right, so let's go to number 6. Number 6 does say to simplify, and there's dividing between the two, okay? But the first thing I want to do is factor this guy. All right, for the sake of keeping this video short, or short-ish, I'm going to stop showing you the tic-tac-toe method. Like, you should just know it. You should be able to factor is what I'm saying. And I'm giving you several examples in this video if you need some help doing that. All right. So, but I do the keep, change, flip method primarily, but some students really like the butterfly method. So first, I'm just going to rewrite this to where everything is factored. That is going to be my step number 1. I'm going to rewrite everything to where it is factored. So it's still dividing. All right. X plus 1. I haven't actually keep, change, flip, or done the tray method. X minus 3, X minus 5. Okay. So now, I have some students that really like to do the butterfly method. If you like keep, change, flip, go ahead. So the butterfly method would put all these 3 together, and it would put these 2 together. So this becomes your numerator, and this becomes your denominator. So you get x plus 2 times x minus 3 times x minus 5 all over x minus 5, x plus 1. Okay. So then we can just cancel stuff out. The x minus 5's cancel, so we're left with x plus 2, x minus 3 all over x plus 1. And bam, that's all she wrote, because there's nothing else I can do. All right, let's go to number 7. Number 7 is done the exact same way as number 6. Step number 1, factor everything. So again, I'm not going to show you all my factoring because you guys should be well experienced in factoring. I don't want to take up your time doing something you already know on a video. So that becomes a plus 3, a plus 2 divided by a plus 1, a plus 4 over a minus 4 a plus 2. Okay. So then, what we're going to get to do is you guys can either do the butterfly method or the keep change flip method. This time I'm going to do just the keep change flip. Last time I did butterfly. So keep change flip means we're going to keep this numerator the same. So I'm just going to have a plus 4 again. Alright, then I'm going to have a minus 4 divided by a plus 3 times a plus 2. A plus 3. A plus 2. And then I change from division, multiplication, and then I flip this guy, a minus 4 times a plus 2 over a plus 1, a plus 4. And then, since this is all multiplying, once you get to all multiplying, you can just start crossing out what's on top and what's on bottom, regardless of what fraction it is. Alright? So, I have an a plus 4 here, I have an a plus 4 here. I have an a plus 2 here, I have an a plus 2 here. And that's all the stuff I can cancel. So I'm going to get a minus 4 times a minus 4, which is really just a minus 4 squared. If you wanted to write that, that would be fine with me. Okay. Over a plus 3, a plus 1. Plus 3, a plus 1. And done. That's as far as we can go. Okay. All right. Let's try to go on to number 7. Oh, there we go. Okay. I'm sorry, we just never told. Let's go on number 8. All right, number 8. Notice what's going on between these two fractions now. It's not adding or it is adding. It's not multiplying or dividing anymore. It is adding, which means you cannot add until your denominators are the same. Okay? So step 1, if you can factor anything, factor it. So 3 over x plus 8. Okay, you can factor x squared minus 64. It becomes x minus 8, x plus 8. Okay, x minus 8, x plus 8. Now, look at your two denominators. Is any one of them missing something? Yes, this denominator on this side doesn't have the x minus 8 that this denominator has. So, I'm going to multiply top and bottom by x minus 8 over x minus 8. Okay, then I'm going to actually distribute this into this denominator, so that becomes 3x minus 24. Alright, now these denominators are now the same, okay, which is what I want. So I'm just going to write it as x minus 8, x plus 8. Okay, 3x, x minus 8, x plus 8, plus 6 over x minus 8, x plus 8. Now that my denominators are exactly the same, I can actually put my numerators together over one denominator, okay? So 3x minus 24 plus 6 becomes 3x. Negative 24 plus 6, guys, is a negative 18 over x minus 8, x plus 8. Now, we're pretty much done. However, you should pause and ask yourself, can you factor that numerator? Well, 3x minus 18. What do 3 and 18 have in common? That's right, a 3. So you could factor out a 3, which would then change this numerator to be, this 3x minus 18 would be x minus 6. Okay, can you do anything with that? No. So then that is as far as you can go. Now, if you could cancel out the x minus 6 with, say, this x minus 8, you can. But if you could, you should do that. All right, but this is as far as you can go. So pretend this is your numerator over this denominator. So bam, that's your answer. All right. Okay, let's go to number 9. Number 9 is adding once again. So what is step 1 in adding? Factor everything. In fact, today, this test, step 1, factor everything if possible. Okay? So anyway, so we factor this numerator and we're going to get x plus 5, x plus 2. Okay. We factor the denominator and we're going to get x plus 5, x minus 3. All over plus 10 over x minus 3. Okay, so look, I want to show you guys a trick. Look at this fraction. You see how this fraction is just already all there? We're not doing anything to this fraction other than it just being its own fraction. I'm ignoring this guy for a second. You notice how these two x plus 5s are over each other on the same fraction? They're not split. They're not over each other in two different fractions. I'm saying they're over each other on the same fraction. You know what you can do? You can cancel them out right away because they're over each other on the same fraction. So that gives us x plus 2 over x minus 3 plus 10 over x minus 3. This is a tricky question. It's trying to trick you because now look at your two new denominators. X minus 3, x minus 3. My denominators are the same. I don't actually need to do any adjustments. I can jump straight into putting my numerators together, which would be x plus 12, because 10 and 2 make 12, over x minus 3. And that's it. That's as far as you can go. That's your answer. Okay? Noticing this saved me a lot of time. Work to notice this kind of stuff. Okay? All right, number 10. That's as far down as I can see it, so you're going to look towards the bottom of my screen. Step 1, factor everything. So that becomes x minus 6, x minus 4, over, yeah, I was right. I was double checking my factoring. X minus 6, x minus 7, minus 9 over x minus 7. Oh snap, what's happening? What do we notice? Once again, this trick happens twice on the test. These x minus 6's can be straight canceled because they're over each other on the same fraction. Okay, they're not on different fractions. If this had been x minus 6, you could not cancel it out like this, okay? That's not allowable, all right? But I can now put my numerators together because my, I didn't mean to make that line, because my denominators are the same, x minus 7, x minus 7. So I can say x minus 4 minus 9 becomes x minus 13, all over x minus 7. Bam. And that's all she wrote. That's all you have to do. All right, guys, really try to focus on factoring and learning little shortcuts like this. They'll save you a lot of time on the test. Good luck tomorrow. You can use a note card. I suggest you make a note card. Let me know if you have any questions. Send me a reminder. Send me an email. Have a great day.